why your large language model is hallucinating, and how to fix it. Here are 8 reasons why your LLM may be hallucinating. Lack of ground truth. If the training data for the model contains inaccuracies, biases, or misinformation, the model might learn incorrect patterns and generate hallucinated content. Overfitting. Overfitting occurs when a model learns the training data too well, including noise and outliers. This can lead to the model generalizing poorly to new unseen data and generating hallucinated outputs. Data biases. If the training data contains biases, the model may learn and reproduce those biases in its generated outputs, even if the information is incorrect or misleading, out of distribution inputs. If the model encounters inputs or queries that are significantly different from what it was trained on, it might generate outputs that are not coherent or accurate. This is particularly true for open domain language models. Misleading context. If the model relies on a context that is ambiguous or misleading, it may generate content that is based on incorrect assumptions or interpretations. Inadequate training data. Limited or biased training data may result in the model not being exposed to a diverse set of examples, making it prone to hallucination when faced with novel or nuanced inputs. Model complexity. Very complex models, such as those with a large number of parameters, might capture intricate patterns in the training data, including noise, and generate hallucinated content when faced with new inputs. Inadequate fine-tuning. If the model is fine-tuned on a specific task or domain without sufficient data or proper tuning, it may generalize poorly and produce hallucinated outputs. Addressing hallucination in NLP models often involves a combination of improving training data quality, mitigating biases, refining model architectures, and fine-tuning for specific tasks. Here's 3 methods to stop LLM hallucination. Method 1. Retrieval-Augmented Generation. With RAG, a query comes into the knowledge base, which in this case is a vector database, as a semantic vector or a string of numbers. The model then retrieves similar documents from the database using vector search, looking for documents whose vectors are close to the vector of the query. Once the relevant documents have been retrieved, the query, along with these documents, is used by the LLM to summarize a response for the user. This way, the model doesn't have to rely solely on its internal knowledge but can access whatever data you provided at the right time. In a sense, it provides the LLM with long-term memory that it doesn't possess on its own. The model can provide more accurate and contextually appropriate responses by including proprietary data stored in the vector database. Once the relevant documents have been retrieved, the query, along with these documents, is used by the LLM to summarize a response for the user. This way, the model doesn't have to rely solely on its internal knowledge, but can access whatever data you provided at the right time. In a sense, it provides the LLM with long-term memory that it doesn't possess on its own. The model can provide more accurate and contextually appropriate responses by including proprietary data stored in the vector database. Method 2. Reasoning. LLMs are good at a lot of things. They can predict the next word in a sentence thanks to advances in transformers, which transform how machines understand human language by paying varying degrees of attention to different parts of the input data. LLMs are also good at boiling down a lot of information into a concise answer and finding and extracting something you're looking for from a large amount of text. Surprisingly, LLMs can also plan. They can gather data and plan a trip for you. And maybe even more surprisingly, LLMs can use reasoning to produce an answer in an almost human-like fashion. Because people can reason, they don't need tons of data to make a prediction or decision. Reasoning also helps LLMs to avoid hallucinations. An example of this is chain-of-thought prompting. This method helps models to break multi-step problems into intermediate steps. With chain-of-thought prompting, LLMs can solve complex reasoning problems that standard prompt methods can't. For an in-depth look, check out the blog post "Language Models Perform Reasoning via Chain of Thought" from Google. If you give an LLM a complicated math problem, it might get it wrong. But if you provide the LLM with the problem as well as the method of solving it, it can produce an accurate answer and share the reason behind the answer. A vector database is a key part of this method, as it provides examples of questions similar to this and populates the prompt with the example. Even better, once you have the question and answer, you can store it in the vector database to further improve the accuracy and usefulness of your generative AI applications. Method 3. Iterative Querying through Forward Active Retrieval Generation. The third method to help reduce LLM hallucinations is interactive querying. In this case, an AI agent mediates calls that move back and forth between an LLM and a vector database. This can happen multiple times, iteratively, in order to arrive at the best answer. An example of this is Forward Active Retrieval Generation, also known as FLAIR. You take a question and then query your knowledge base for similar questions. You'd get a series of similar questions, then you query the vector database with all the questions, summarize the answer, and check if the answer looks good and reasonable. If it doesn't, repeat the steps until it does. Speaking of questions, if you have any, be sure to comment below and subscribe to my AI Crash Course to stay current on all AI, LLM, and machine learning developments.